All right. Hi. So this is the coffee cup calorimeter, and before we get into the actual question, I think it's important that we understand what it looks like and some important ideas and sort of equations to know as we get into this. So this is what we're dealing with. So you can imagine if we have calcium chloride in here. This is the coffee cup. It looks like this. So this is what we're dealing with. And so as the temperature of this goes up, we're going to be looking at like thermochemistry. And so so the temperature goes up, we want to understand these important concepts. So as temperature goes up, Q of the reaction, negative Q of the reaction equals Q of the water surrounding the calcium chloride. And the Q of the reaction, as the temperature goes up, is exothermic. I can explain why this is, but that's not really the purpose of this video. And for your test, I think it is good to just remember this. I remembered it via colors. Temperature goes up, reaction is exothermic, the water is endothermic. Because the water is, just remember it. And so the opposite's also true. It's vice versa. So as the temperature goes down, the reaction would be endo, the water would be exo. We're going to see that in this next little equation. And right here, this is kind of the same thing. And these are some these are important equations to know. So delta H, enthalpy, is Q of reaction divided by moles. And Q of H2O is equal to MCAT, or MC delta T. Okay, so here's how we, if you've seen the other videos I posted, I think it's helpful to know for the test. I may be wrong, but this is the way I'm going to teach it. Is I remember there's sort of like, kind of like the way he teaches in class. It's like step 1, step 2. I remember like key buzzwords, and they go off in order, and they kind of lead into each other. So the first question, as always, you see an equation in any one of these tests right here, you have to ask yourself, is this guy balanced? Luckily for us, yes. I'm not going to get into how to balance. We're on the third test, guys. We got this. Yes. So we can just look at all these coefficients as they are. And luckily for us, it's always 1 in front of these guys. I will be teaching you what to do if it's not 1. For this, it's 1. So it's going to be nice. It's just going to be like the sort of like the raw, the insides, how we're going to deal with just it in general. Okay, once and givens. I've written out a little bit of kind of what we're aiming for, what's going to be the end goal, what we're actually going to turn in and circle on the test. Delta H is going to be equal to QX reaction divided by the moles of the participant. I can never pronounce that word. I'm sorry, guys. Okay, this brother right here, we're going to be looking at him, and we want to know right here, how many moles of him do we have? We need to find Q, and then bada bing, bada boom, put that in kilojoules over moles, and we're golden. It's a free hundo. It's easy, guys. It's not, but you got it. It's easy for y'all. Okay, always, in every one of these questions, especially if there's a limiting reagent, always moles. It's always the moles. Okay, so we want to find the moles, but actually I skipped a step. So it's once in equations, but it's also givens. So the givens are pretty obvious in the question. It's just kind of just straight up. I'm gonna write these down. So the givens. So we have 40 ml, and this is, I don't know how much it is, and this is 0.1 molarity of AgNO3. And there's also, I'm gonna color code this for y'all. There's 50 milliliters of 0.1 m HCl. Okay. What else do we know? We know the change in T. So we know T initial is equal to 23.4 degrees Celsius, and T final is equal to 24.21 degrees Celsius. That's awful handwriting. I'm sorry, y'all. Okay, so for these, we can keep it in Celsius because it's changed in T. So like imagine if we added 273 to both of these, then we subtracted, the difference would still be the same because you're adding the same amount to each. As long as it's delta T, you can keep Celsius. But if it's anything other than that, be warned. You need Kelvin. So I think this is all we know so far. Oh, we also know the density. Density is going to be equal to 1 gram per milliliter. Isn't that so nice? Isn't that such a nice conversion? I'll be doing the stoic maps so you can understand what's going on. I'm not going to just like transfer it straight from grams to milliliters and milliliters to grams or whatever. You don't have to worry about that. I'm gonna help you. Don't y'all worry. We also know the C in MCAT. It's gonna be right there, and we're gonna take a look at these at the units are in grams per milliliters. That's obviously density, and this is gonna be our C constant. It's gonna be in joules over grams Celsius. Okay, so that's the specific heat of the solution we're dealing with. Moles. How are we gonna find these moles? Well, you see, guys, it's pretty easy. You gotta remember the triangle of the moles and the molarity, but we dealt with that already. I think we got that, guys. I'm just gonna do this and y'all could watch. So we have 400 milliliters of that and 0.1 that. So that's equal to 0.04 liters times 0.1 molarity, and this is going to be of AgNO3. And then there's going to be 0.05 and 0.1 again. This is going to be for the HCl. And so now we're going to find the moles of each using some magic. Alright, so 0.004, obviously guys. 0.004, 0.005. Okay, and so this is moles of, I should have color coded this, but y'all, I trust y'all. So now, in this question, remember, I have the little things on the sides. We go from balance, yes or no. What do we want? What's the equation going to look like? What equations do we need? And then some moles. Okay, why do we need the moles? Well, this is going to involve limiting reagents. So the question we are asking, always remember that. Don't get stuck in the motions, guys. What are we asking when we want this? We want to know how many moles of AgCl are we going to get in the end? So what's holding us up? So you have how many moles is this going to produce of AgCl? And how many moles of AgCl is this going to produce? Well, we obviously know how to convert from moles to moles. You need a molar ratio. Ours in this case, so if we go 0.004 times 1 mole over 1 mole of each, that's obviously going to get us the same number. In the case where it wasn't 1 over 1, you would multiply by the molar ratio that we all know. I've showed this in my other videos as before. So that would give you which one gives the least amount of AgCl. And so it's just 1 over 1 though. So we know the limiting reagent, it's going to be a smaller number because that's the one that produces less. And so it's going to make it a lot easier just transferring. So there's going to be, the limiting reagent is AgNO3, and it is going to produce 0.004 moles of AgCl. And so this is why we needed this. Why we needed this, is because of this. We want the Q of the reactant over the moles of AgCl, because AgCl is our fancy little solid that we produce. And so this is important. we need this number. And so that's what all this fuss was for. We wanted to find each different thing in this. And so all of this fighting, the limiting reagent, was for the moles. And so the moles end up being this amount right here. Yeah, and so it's just the same number. So if there was coefficients, it'd just be the molar ratio, which I'm sure we all know how to do. I kind of went over that, and it'd just be how many moles of AgCl are we able to produce. This is just gonna be a one to one ratio, just to give you kind of like the skeleton. It's you combining all of your skills. So the reason that there's limiting reagents in all of these tests is because we add more and more in each. We add molarity, we add whatever, and so it's just mixing the skills. I'm confident that y'all will be able to find the amount of moles that are produced of this. In this scenario, we know that it's 0.004 moles of AgCl. I'm going to highlight this. This is an important number. This is going to be the bottom number that is up here. And so now we need to find Q. How do we find Q? It's MCAT, MC delta T. Remember to be careful doing this, because they are trying to trick you here. And so we're going to solve for each letter slowly, and we're going to solve for Q. Because remember, it's not just MCAT. It's Q equals MCAT. And Q is what we're trying to... That's a G. My bad, y'all. Q is equal to MCAT. And Q is what we're trying to find. So let's find that. Okay, M, total. How do we find the mass? Well, luckily for us, earlier they gave us the density. We know the density, we know the volume. Bada bing, bada boom, we can find the mass. Delta density, or I guess we use D in the class, is equal to mass over volume. So if we know the density is 1 gram per mole, 1 gram per milliliter, and we know the volume in milliliters, we can just times V. And so dV is equal to M. That's going to be equal to 1 gram per milliliter times the total. Remember, it's total. M total. And that's going to be 50 milliliters plus 40 milliliters, which is 90 milliliters. Remember, this is in milliliters, not liters, guys. So 90 milliliters, that's going to be equal to the mass. Milliliters cancel, 90 grams. So there's 90 grams of the solution for this Q. So we can kind of make a little arrow up here. This is going to be 90 grams. C. Well, C was at nice. Oh, also, to be careful, remember to write your units, because these units are going to cross and cancel and do whatever and do all sorts of fancy things. It's good to just remember them. I struggle with that. So I think I would like to share that knowledge with you. Obviously, you all already know it too, but I'm just trauma dumping for my last test. C. What is C going to be equal to? Well, it was up here. It said right here. I underlined it. 4.184. 4.184. And what's the units attached with that? Remember those. Yeah, so that's kind of just a straight plug-in right there. Plug and chug, as it goes. That's my life. 4.184 joules per gram times Celsius. Now delta T. How do we calculate delta T? Well, delta means change in, and we know the initial and the final of T. My handwriting is so awful that we are actually going to look up here, because I don't want y'all to have to deal with that. So, putting that in our trusty calculator, final minus initial, what's the delta? It's going to be 0.81. And that's going to be degrees Celsius. So we're actually going to move this guy now a little bit lower. Don't mind that washing machine. We're gonna Actually, you know what? We're just going to rewrite it right here because it's going to be closer anyways. So Q is equal to the mass, which was 90 grams, times 4.84 over grams times Celsius times 0.81 degrees Celsius. And so these Celsius, I guess, are going to cancel. These grams are going to cancel. And so Q is equal to the sum of all of these, not sum, I wasn't even showing. Cancel. And so we're just going to plug this into our calculators. 90 times 4.184 times 0.81. 305. But wait, we're not there yet. This is going to be equal to 305 joules. Right? Yeah, joules. So now we need to put this into kilojoules though. So Q is, I'm just gonna do it like this, slash, the conversion from joules to kilojoules is to divide by 1,000. So you do it times here, times 1 over 1,000. And that number is just gonna give us 0.305 kilojoules. So we have this number. And so the Q of the reaction, as we stated above, is equal to negative of that. So it's going to be negative 0.305 kilojoules divided by the amount of moles of AgCl that we found. And we found that earlier right up here, 0.004 moles of AgCl. And this number, remember, yeah, the negative, it's negative. This number, the delta H, is going to be equal to, plug this into our calculators. 76.25. This is going to be kilojoules per mole. And that is going to be your final answer.